Hello everyone, in this video I will be discussing the formation of triglycerides from glycerol and fatty acid, and then we'll also discuss once again production of biodiesel via trans esterification. So 13.2 and 13.3. Alright, we've talked about this in the last video, but a triglyceride is a triester that is made using one glycerol molecule and three fatty acid molecules. So the glycerol is the alcohol here, and the fatty acid would be the carboxylic acid. So it is just a regular condensation reaction or esterification, specifically in this case. The only interesting thing, it's not even that interesting, is that the glycerol has three hydroxyl groups, so you need three carboxylic acids to react with it. Now, water groups are given to you in your data book, so the fatty acids, the list of fatty acids is in page 7. And you can find the structure of glycerol on page 8, which is right after. So page 8 has a lot of different things. We're going to look at every single one of them, but we're just going to look at glycerol here. Glycerol is also called glyceride. It has a lot of usage. It's a very, very important and useful product. You see it in a lot of skincare, like moisturizers, because it's a humectant, so it holds a lot of water. I have a bottle at home. You can buy it from the chemist. And they also use it to make the transparent soap that you may see that has like pretty flowers and things like that. All right, let's give you an example. There's a bit of drawing in this topic, so just know what you're trying to show and be very careful. So the question here is to write an equation to show the formation of a triglyceride that is made from glycerol, and the three fatty acids are steric, linoleic, and lauric. So everything is given to you in the data book. Now, I will say with confidence that you will never be asked, or you most likely will not be asked, to write the structural formula of a fatty acid and then draw out, like, I don't know, 11 carbon. So normally some form of condensed formula will do. If the question just says structure, then any structure will do. Just use the one that, is easy for you. So glycerol, I'm just going to do exactly the form that was given in the data book. So it's a trial. Can you name this? Surely you can. All right, so OH, and then there's an OH, and then there's an OH. So this is glycerol, and the three fatty acids are lauric. So lauric is C11H23COOH. Now I will say this, I much prefer the condensed formula because it makes it a lot easier to flip and still show the other end of the molecule. So I'm just going to use a condensed formula here, but lauric is the very first fatty acid in the table. Steric is CH3, CH216 COOH, and linoleic is, oh, okay, I'll do this. CH3, why did I pick this? Sometimes I wonder. 4 CH, CH2, and then CH26. It is good though. You can see that there's a little bit of unsaturation in the last fatty acid here. All right, so these are the three fatty acids, and then they're going to combine in a condensation reaction. Probably need some acid. The standard catalyst for condensation is sulfuric. So I'm just going to write that here. The body probably uses some other things, some enzymes. Now, because this is a condensation reaction, obviously water will be produced. And because you have three hydroxyl groups, each is going to react with one carboxyl group. So in total, you have three water molecules being produced. So this is going to be 3H2O for sure. And you just need to draw what's left. So the glycerol is going to retain its structure. And this is why you have one molecule that is very, very big, because you just combine three massive fatty acids into one molecule. So that's why lipid is so nonpolar. So whatever is left of the carboxyl group is going to go in here. So the oxygen is still here. Let's draw that first. And then the C double bond O is going to come in. I'm going to get, I feel I should have gone a different color for the fatty acid now that I think about it. Anyway, this CO is going to be here. And then you just write the rest of the fatty acid. So this is why I like the condensed formula or the semi-structural formula, is that you can very easily flip and then you can still see the CH3 at the end. And then I'm going to do it for the second one. So this C double bond O is going to join the oxygen. Somebody's going to ask whether the order of the three fatty acids matter. Not really, no. Unless the question specifically say this goes first. But in reality, there's no way of controlling which of the three fatty acids going to be attached to which of the three hydroxyl and the glycerol. So I honestly don't care which one you draw first, as long as you have the three that is specified in the question. I just gone off like increasing length because that's where I got the order I got the fatty acid from. Oh my god. Okay, sorry, that's wrong. I have to flip this. CH2 and then CH2 4 CH3. Okay, so this is the triglyceride. Not to be confused with trisaccharide, which we'll look at later for another molecule. But you can see that it's a triester. It has three three ester groups present. Don't forget the water. Okay, you need to be able to do this yourself, so I would recommend that you try with three other fatty acids at some point. It's not hard, but people make a lot of small errors, and especially not drawing the ester link properly. I saw a lot of version when it's like this, so people forget the oxygen remaining from the hydroxyl group, or something like that. So it just takes practice and care, and you should be able to get it. All right, a lot of you should know this already, but let's just talk about different functions of lipids. So once you make the triglyceride, what happens to it in the human body? And the main function of lipid, I suppose, would be for energy storage. So it's from energy storage. And out of all of the different types of macromolecules, this is the most energy dense form. This little table is actually given to you in the data book as well. We'll talk about this a little bit later with calorimetry, but fat and oil, on average, 37 kilojoules per gram, whereas protein and carbohydrates have less energy. So energy storage is probably the main function, but obviously there are other functions such as main component of cell membrane, or the biopupil would know this. Insulation is another important function. It is also involved in cell signaling molecules. So steroids, well, there's a lot of hormones are lipid based. So it's not just for energy storage. And not every type of lipid is triglyceride either. It's just that we only look at triglyceride in VC. Anyway, it's a good idea to know the different functions of lipids, mainly for storage and then some other things. I want to quickly talk about this function, of course. So plant lipids. Plant lipids is a fun way to say oil. But you can use animal fats as well, obviously. Especially when we talk about waste oil or waste fat that can be used or upcycled to produce biodiesel. But plant lipid can be used to make biodiesel via a process called transesterification. Probably the best word to say, and to sound smart. I really enjoy saying the word. And this is a very good opportunity in the exam to link Unit 3 and Unit 4 together, because now is the time when you have to be able to and fully understand the chemical equation for production of biodiesel. So let's do that. Transesterification. Now, transesterification is essentially a combination of two separate chemical reactions. The first one is hydrolysis. So your starting point is the oil or the fat. So your starting point is a triglyceride. So you must first hydrolyze the triglyceride. And then once you've done that, you're going to have a condensation reaction between the fatty acid and methanol. So that's the second step. So two steps. And if you combine them, you get transesterification. All right, so I'm going to draw that out. I'm just going to use the molecule that I made earlier, which is, you know what, it's too far back. I'm just going to redraw it. So the molecule I made earlier was a triglyceride. So let's say C. So let's just start with the molecule from earlier. So it's a triglyceride that is made from lauric acid, and then the other one was steric, CH216. Oh, do I have to write this again? Okay, that's okay. I'll do it again. I can't remember which one it was. I think it was linoleic. I think I'm too young to have short-term memory loss. CH2CH. You know, they use to say that biology, chemistry people have a good memory. There's a lot of memorization in chemistry. All right, so this is a triglyceride. So the triglyceride is your starting point. I'm starting to wonder whether I'm going to fit this in. And you're going to hydrolyze it. So hydrolysis just means that you're breaking the ester link to reform the reactant. So essentially what you're doing is the reverse of the reaction that we drew earlier. So you need 3H2O for that process. And you're going to reform. It normally requires potassium hydroxide or some strong base catalyst. If anyone has watched Fight Club, like Liar, which is the thing that they put in to make soap, it's basically potassium hydroxide. They just need something to hydrolyze the fat so they can get the fatty acid, and then you add a sodium, and saponification is that process. If we have time, we'll talk about saponification, but probably not in this video. So you're just going to reform. I am so not going to have enough room for that 3 giant fatty acids. So my apologies, but I want to do the condensed the other formula. So the first one, all right, be nice. CH3, CH210, COOH is the first one. So all I've done is to flip this to, just so that it doesn't look weird. And then the second one is CH3, CH216, COOH. And the third one, I'm just going to collapse this because I can. So C17, H31, COH. I just don't have enough space here, but if you do, you can rewrite the whole thing. So the first step is hydrolysis. You start with the triglyceride plus water to produce glycerol and 3 fatty acids. So if we go back to this, step 1 is triglyceride plus 3 water. The number actually matters here, I could say, and it's going to produce 1 glycerol and 3 fatty acid. So it's just your standard hydrolysis to reform the alcohol and the carboxylic acid molecules. So you need a catalyst. And the second step is going to be condensation. So the main purpose of the hydrolysis step is just to get the fatty acid out. And the fatty acid is going to form the bulk of the fuel because it has a very long hydrocarbon chain that can be burnt. However, you can't really burn, you don't really want to like pour an acid into your fuel tank of the vehicle because it's still an acid that can corrode materials. So the goal of the second step is just to sort of not neutralize, but make the acid a little bit less reactive by converting it into an ester. So I'm going to do this 3 times. So the first time is the first molecule is for this acid, and I'm just going to react it with a methanol. So you basically have a hydrolysis, you break an ester, and then you form another one. So CH3, CH210, COOCH3. So this is just your ester, and then you get a water molecule out. Now the acid here, this is lauric acid. So if it is lauric acid, then the ester is going to be called methyl laurate. So it's kind of like the way that you would name any ester, except instead of counting how many carbon is in this acid, you just use the common name of the fatty acid. And then you can form another ester from the second fatty acid that was produced earlier. So this one. And it's the same reaction. I encourage you to try to draw it yourself. I'm probably going to need some catalyst. Normally it's not added, I have to say. No, they normally just mix it with KOH and then it kind of just reacts. All right, COOCH3 and then H2O. So this was steric, I believe. There's an I in there. So the ester is going to be called methyl stearate. Okay, so just the last few letters just get changed into an ester convention. And then the first one, which I got lazy, so I just wrote this. This one was linoleic, I think. So if you react it with CH3OH, you can get C17H31, COOCH3, and water. So the ester in this case is going to be called methyl linoleate. So these molecules, these three, are biodiesel. So biodiesel is basically, I'm sure you know this, fatty acid methyl ester. It's an ester that is made between a fatty acid and methanol. You can have the same biodiesel. Like these three can be identical if you start with a triglyceride that has the three identical fatty acids. But in real life, like the majority of fats and oils, probably you have varying compositions of fatty acids in the triglyceride, which is why biodiesel doesn't have one single formula because it's kind of hard to know which of the fatty acids you're going to get depending on the types of oil. So the second step, if we go back to this, is basically you have the three fatty acid. If I just want to generalize and add them together. So the three fatty acids will react with 3 methanol, and that is going to produce 3, well, there's 3 water, that's for sure, and which I didn't even draw. Yeah, I did. I did that subconsciously. And 3 fatty acid, subconsciously, I don't even know what I'm saying, methyl ester. Okay, so, and then you get the 3H2O. So that's in general, but you need to be able to do this yourself. I don't think memorizing too many things in this topic is that useful. You really need to go for a deeper understanding. And if you understand how hydrolysis and condensation works, in general, it shouldn't be too difficult. So that's just the overall. I think a 3 here is really, I should have done that. Now, the interesting thing is in the process of transesterification, essentially what they do is they combine these two reactions into one. So you can see how the water will get cancelled out if I add these two equations together, and the fatty acid will be cancelled out because they are intermediates. So this would be the overall equation. So you just have a triglyceride with 3 methanol producing glycerol and 3 fatty acid methyl ester. So whenever the question asks, if the question ever asks you to write an equation for transesterification, it's this equation that they are after, which is when you already combine the two processes of hydrolysis and condensation together. So this is an example of what it might look like. In this case, this is a lot easier because the 3 fatty acids, methyl esters, are made from the same fatty acid. So you just need to write these ones and then put a 3 in front of it. But if I were to add the example that I just did earlier, then you're just going to have 3 biodiesel molecule here. Again, there's a lot of drawing in this topic. I don't think I've said that before though. So there's a lot of drawing in this topic. You just have to practice the drawing. I think that's it actually, and go work on the worksheet questions. Thank you.